Now we need to add in how we calculate elasticity of demand. And we can do that where price and demand are related by x equals f of p. So x is some function of p. Then our elasticity function, E of p, will be negative p times the derivative of f of p all over f of p. Or we could recontextualize that in sort of the format we've been working problems. Keep in mind now that we would want to construct a linear function of the form p comma x, where p is the independent variable. That output then will be some function x of p is equal to m times p plus b, meaning we can rewrite this function as negative p times x prime of p, so the derivative of that linear price demand function, divided by the original price demand function, where again p is the independent variable. In example 6, we're given a price demand function for a particular product. We want to find the elasticity of demand function. In order to do that, we need to find x prime of p. We could use Symbolab for that, or this is a relatively easy derivative to just do in one step if we're getting comfortable with these. So this would be negative 9.0191, meaning our elasticity function, E of p, would be negative p times negative 9.0191, all of that divided by the original elasticity function, negative 9.0191p plus 613.7396. And then just cleaning up the numerator a little bit, our negative times negative will give us positive 9.0191 times p over that original elasticity function. Next, we want to calculate E of 32.3, and then in part C, interpret that result. So in Symbolab, we'll input our elasticity function. And evaluate that for p is equal to 32.3. We get a result of 0.9035. In this case, our value is between 0 and 1, so we have a case of inelastic demand. And to interpret that, we would say that at a price point of $32.30, that's the p-value that we plugged into the elasticity function, or the value for p. At a price point of $32.30, since demand is inelastic, we should increase price to increase our revenue. That increase in price will be met by a smaller decrease in demand, so total revenue will increase. In example 7, we want to repeat the same process. First, we need to find x prime of p, which in this case will be negative 0.5032, meaning our elasticity function will be 0.5032 times p divided by the original elasticity function. Then we want to calculate E of 477.17. We'll enter our elasticity function. And evaluate it for P is equal to 477.17. And we get exactly 1. Since our value for elasticity is exactly equal to 1, that tells us that at a price point of $477.17, revenue is maximized. Which is another way of saying what we've found is the optimal price point, or we're currently selling this at the optimal price point, because any change in price will be met by an equivalent change in demand, so the change in price will yield no change in total revenue. We're already selling this product at the optimal price point, which maximizes our revenue.